Okay, morning everybody. Okay, today we'll be going to the last section of practical electricity, whereby we talk about the six uses or six precautions that we use you actually encounter at home when using electricity. Okay, now the six safety feature that we have at home. Okay, commonly found at home and in most appliances. Okay, let's take a look at what they are. Now the six safety feature are the fuses, earth wire, 3-pin plugs, switches, circuit breaker, and double insulations. Now, when you talk about these six safety feature, the important thing regarding this topic is to know for all the six of them, to understand firstly how they works. Okay, how it works. Okay, and when in understanding how it works, sometimes it encompasses the placement, the location of the appliance, the safety feature, what location, which wire are the safety feature are being placed at, so that it can actually perform its correct function. After that, the second thing that you need to take note is what are the keywords that you need to include when you talk about when explaining to the marker how does the feature works. The keywords in highlighting the positive effects or positive outcome of these safety features. These are the two main things that you actually need to take note when you run through this topic. Other than that, okay, what the other one that we look at is number 3 is how many feature are we looking at. Okay, because some of the features you'll see that they will occur separately. For example, under double insulations, usually we will see them on its own, but there are some safety feature that you look at, your fuse, your earth wire, they actually occur together. So here we will look at the features one by one, but in real life or in the applications part or in the appliances, certain safety features are actually mixed together. So so-called you have a combo usage. Okay, so just take note of these three things when you run through this topic here. Now, first thing we look at is your safety, your fuses. The safety feature is your fuses. Fuses, I think most of us, we are quite familiar with it. It's just a piece, usually you see it as a small cylinder tube like this. Okay, and in this cylinder, the fuse is actually just a piece of wire here. This piece of wire here. Okay, this is a piece of wire that actually acts as a safety precaution. What it does is it actually melts, okay, when the current become too hot. Okay, each of the fuse, each of the wire are actually specially calibrated to melt at a certain degree, certain current. Okay, so this is what I mean by the rated value. So which means if the wire is manufactured such that it will melt at maybe current 5 amp, which means the rated value for this fuse will be 5 amp. So anything that is 5 amp and above, the fuse will get hot and it will melt straight away. So one of the common things that you actually see, one of the keywords that you see is actually greater than the rated value. Okay. The next slide here, we will look at how it works first. Okay. Now, uh, now currently you will find that for fuses, right, you actually want to use the fuse rating, or you want to use a fuse that's actually slightly higher than the normal current. So for example, your normal current that's working in the circuit is 4 amp. So you actually want to use a fuse that is like slightly higher, so that your appliances still work when I switch on the appliances. So example, if I have 4 amp current running through the circuit, I will actually want to use a 5 amp fuse, so that in case, let's say example, I have 4 amp, the working current is 4 amp, but when I switch on the circuit, or when it's cold weather or hot weather, whereby the current in the appliances actually fluctuate, maybe like it somehow it just fluctuate maybe to higher than 4.2, the circuit will still work as per normal. There will be no, the fuse will not melt because it's still below 5 amp. Okay, but I will not want the fuse to be too high, because I still want the appliances, in the case of high current, I will still want the fuse to be able to melt and to be able to stop the current. So that's why my fuse rating, I cannot put too high. Okay, so example, if I have 4 amp, I will not want to use a 10 amp fuse. Okay, so 10 amp fuse means maybe I only allow 10 amp and above. I only stop 10 amp and above current when there's 10 amp, when there's 10 amp or more than 10 amp current flowing in the circuit, I will only stop this rating. So what happened to 5, 6, 7, 8 amps? They are actually higher than what I needed, and they are dangerous also. But because I use a 10 amp fuse, my fuse will not be will not take into effect for current less than 10 amp. Okay, so that's why choosing the fuse rating is actually important. And talk about fuse rating, in the market, the theory is that you're supposed to choose a fuse rating that's higher than normal. But in the market, I can't really manufacture any fuse with any rating. So as a result, I will standardize certain fuse rating for the market for easy of purchasing or easy of standardizing. So the fuse rating that you see in the market actually ranges from this number 1, 2, 3, 5, 10M, and even 30M, 13M. They are higher fuse rating, they are higher 20M fuse, all these things. Okay, but in your syllabus, usually you run up to 13M, which is what we call the common appliances fuse. Now, one of the things that you need to take note is when how fuse are being connected and how fuse take effect. Okay, so now when fuse is as a safety feature, okay, it is always connected to the live wire. Okay, so which means if you have appliances, okay, the live wire, okay, this is the light bulb. The live wire is whereby the current flow out from the power source. So it will be flowing out from the power source. Okay, so you'll be going from the power source, go one round, okay, so from the plus to minus. Okay, so this will be the current. Now, what happens is in your fuse, you have to actually plug the fuse at the live cable here. So this is the fuse. Okay. Now, I have to leave it in the live cable, in the live wire. Why? Because only when it is at the live wire. So what happens when there's a fault occurring? So let's say when do a fault occur? The fault will occur when the high current actually flow through the circuit. So which means the circuit here, you actually allows current to flow through, normal current. So what happens when there is a fault? And what's the result of the fault? You have a high current, excessive current higher than your normal one flowing in the circuit. So what happens is that your high current will surge through the circuit. The light bulb will be brighter than usual. So what happens is in the event of high current, my fuse will melt. The piece of wire will melt. And as a result, you will find that the circuit will be open switch or will be open circuit. And what is the benefit of this when I put this in live, when I put the fuse and live wire, is that my appliances here will be permanently disconnected, okay, from the live. So there will not be any danger of like people accidentally touching the appliances and get electrocuted because it's not at the live, because the appliances is not at high voltage. So the other keyword that we commonly use when we elaborate the feature of fuse is high current flowing through, and what it does is it actually disconnect the appliances from high voltage. And what it does, it will actually stop the high current from flowing, and indirect, and after that you will prevent any electrocution. Now, just take note of this. This is what we mean by the keywords that you mentioned and that you need, okay, when you write out the feature of your for your fuse. Okay, so these are the keywords that you always use. And the other thing to take note is that for fuses, the main thing about fuses fusing, okay, is actually because of one thing, because I want to protect high current in the appliances. Yeah, I want to protect high current from flowing through the appliances. And because I prevent high current from flowing the appliances, the first utmost purpose of using a fuse is actually to protect the appliances. I don't want the high current to flow through the appliances. So the first line of protection I use for fuse is actually I will actually protect the appliances. And after I protect the appliances, I will actually indirectly protect the user. So if you look at the way the fuses work, okay, by high current flowing through, it will melt, it will disconnect the circuit. So the main purpose of fuse melting is actually firstly to protect the appliances first. Then after that, protect the user. So here, student, you need to be careful that in this safety feature, the first features fuse, the main aim is to actually protect the appliances followed by user. The rest of the subsequent 5 feature, you'll find that the first line of protection is actually protecting the user. Okay. Now, earth wire usually you will see it in a 3-pin plug, or usually, and how do you recognize it? Is the cable is always a yellow-green cable. Okay, it's a cable that is wrapped purely with yellow and green. Okay, and it's usually a cable that is low resistance. Okay, and the other feature that we have is actually connected to the metal casing outside. It's not connected to the heating element or the light bulb, or it's actually connected to the casing of the appliances. Okay, now how does earth wire works? Okay, earth wire is actually connected to the casing here, which is what you see. So what happened in the circuit is that when I have current flowing through the circuit here. I will actually flow through the appliances, and the current will flow out of the appliances through the neutral. Where this is what the normal path flow for current in the working appliances. So now what happened is, when the live cable here, okay, maybe due to accident or wear and tear, it actually broke off. And what does it do? That it actually touches the metal casing now. Okay, it's just by fluke of luck or by accident. Okay, so what happened now is that the live cable actually drop off. Okay, then what it does is actually touches, this portion actually touches the metal casing. Okay, so now what happened is when it touches the metal casing, this is the problem. Okay, your current will actually flow in the metal casing, and because the person is touching, okay, and current will flow through the person, and that is actually a hazard. Okay, the person will get electrocuted. So now what you do is, with the users of your earth wire, what it does is that your earth wire is a low resistance cable. So when the current flow through, okay, to the appliances, okay, the current flow through there, and the person touch it. Okay, so now the current flow through, he will actually have a choice. Is whether when the person touch, do I want to flow to the person, or do I want to flow to the path of low resistance here? Okay, and after that, your earth cable is actually connected to the grounding at the flat or at your houses. Okay, so now you have two paths. One is flow directly to the person touching it. The other one is flow around to the, from the metal casing down to the earth wire. Okay, so now the current has these two choices, and the current will make the best, smarter choice. He will actually flow the path with less resistance, the least resistance, which means that the earth cable path will be the choice, that there will be the chosen path that the current will flow, because earth cable is always a low resistance cable. Current always like to flow low resistance path, and as a result, they will actually flow, current will actually flow to the from in the casing, and after that go out to the earth wire. And this is how I prevent the person from getting electrocution. Okay, so this is one of the things that you have to take note of the users. Now for your live earth wire, right, one of the keywords that you look at here is actually this, okay, whereby you need to tell the marker when you're writing, is that when does it occur? It will actually occur when your live wire touches the metal casing. So these are the two keywords that you always write in your answer. Okay. Now the third one here, okay, for this part of the video, this is the third one that we will go through. Now for the third section here is plug and socket. The plug and socket is quite easy because it actually encompasses the first two users, your fuses and your earth wire together, all in one. So it's like a two-in-one devices, okay, whereby I actually have the earth wire and I actually have the fuse. Okay, so which means that the current will flow through the earth live wire, you'll go through the current will flow through the live wire, and after that you go to the appliances, and after that you exit the appliances through the neutral wire. So like all normal case, okay, you will have live and neutral cable in the appliances. Okay, so this is your live, this is your neutral. Okay, then at the same time you also have earth wire, okay, attached to the appliances. So where does all these three cable connected to? Okay, other than the appliances, these three cable are actually connected inside the plug. So what do you do is, with all the plug, I will plug it inside the power socket. So you will find that this power socket actually, or this plug actually has two safety feature inside. So the reason that people use plug, 3-pin plug, is actually to encompass the three users or the two safety feature that we have. So that is one of the feature that you have for this third feature lah. Okay, same thing here. When you look at 3-pin plug, you need to look at the fuse rating. Okay, and take note of the color code lah. Here the color code of the 3-pin plug, take note. Okay, live wire is brown, neutral is blue, and earth wire is green and yellow. Okay, so take note of the three colors for the three wires inside the metal plug, inside the power plug. Okay. Now, the next three users, I will continue in the next video, because if not, if I run all the users in the one video, it would be like a 20 minutes or 25 minutes video. It will be too lengthy for everybody. So now, in the meantime, okay, for this particular video, you can actually rewind back, or you can click to the front to run through what are the keywords that you have. You might also want to write down the keywords on your notes, but it's actually quite lengthy. So it's good to have good habit to highlight the keywords, and like I mentioned, to know where are the safety feature being used. For example, fuses on the live wire, the earth wire is connected to the metal casing. So you need to know where are the users, where are the locations. Okay. So the next video will talk about the next three features, and same thing, the keywords also. Okay. So for now, this is where I end off. Okay. If not, if anything, just leave your questions in the comments bar. I'll get back to you ASAP. Okay. See you. Bye bye.